Hello and welcome. My name's Ryan. I'm also known as RM2KDev. In this video, we're going to continue on with our top-down shooter project. We're going to add some projectile weaponry. So basically, the player's already holding a rifle. We've already got the firing animation in here. So the next thing I think we need to do is make it actually fire some bullets. So what I'll do is I'll add an event of type mouse global left pressed. Now, inside of this event, what I'm going to do is I'm going to say SPR, oh sorry, no, I'm going to say image, no, I'm going to say sprite index, sorry about that, equals INDX equals SPR player underscore fire. The other thing I'm going to do is I'm going to say alarm 0 equals 7. Now it's going to give us 7 frames, and then we're going to set the sprite back. So in alarm 0, we're going to add sprite index equals SPR player underscore walking. So basically, when we click the left mouse button, we should fire. 7 frames later, we will be transitioned back to the standard walking animation. Now, I don't think we're getting enough time for the animation to play, so let's increase that timeout from say 7 to 25. Let's have a look. We're just gonna have to play with these numbers until we get it right. So what you'll notice is that we're not getting any animation. It's not a timer thing, it's that the animation isn't happening. So what we need to do is need to say image underscore we need to say image underscore speed equals 0.5, and then back in our alarm we need to say image underscore speed equals 0. Let's have a look if that's going to give us some nice animations. There we go. So what you'll notice is we're getting some firing animation. If we're not moving though, we're not getting any firing animation. So we need to correct that somehow. Let's have a look. Global left pressed. I think that's because of the way that we've implemented this image speed thing here. So instead of saying 0, what I'm going to do is I'm going to say lerp from image speed to 0 at a speed of 0.1. Now that should give us a nice animation. It basically gives us a little bit of time to get the animation out from the gun. So if we're repeatedly clicking the button, we get some nice speed. Otherwise, it slows down for us, and it also gives us a nice way of slowing down the animation when the player is walking. There we go. So that looks a little bit better. Quite happy with that. The next thing we need to do is actually fire a projectile. So let's create a sprite. We call this sprite underscore bullet. I'm going to edit the sprite. I'm going to add those from my strip here. These are going to be the frames that make up that bullet. The first 5 frames here are the initial launching of the projectile. We're also going to need another one for traveling. I'm also going to send to that sprite as well, and I'm going to duplicate it this time. And I'm going to call this one here sprite bullet underscore travel. I'm going to edit the sprite. I'm going to get rid of the first 3 images, just so that we get this nice last frame of animation here, where the tail of the bullet animates for us. And again, make sure that's centered and select OK. Let's create an object for that. We'll call this obj underscore bullet. I'm going to give it the initial bullet animation as well. Now in its create event, we're going to add a image speed control as well. So we'll say image speed equals 0.3 and press OK. We also need to say uses physics and create it as a box shape. Actually, no, let's create it as a circle shape. Circle collisions are always easier to work with, and they tend to work just a little bit better than square collisions as well in terms of performance. Now for density, we're going to set this to 0.1. Doesn't need to be too dense. The rest of these values look pretty good. That will do it for our bullet, I think. We're going to jump back into our player, and in the global left pressed event, we're going to say bullet equals instance create. We'll just create this at the center of the player for now, and we'll call it object bullet. And let's have a look what happens. So what you'll notice is we're creating bullets now. They're animating, but they're not moving, and they're also not in the rotation that the player is facing. So the next thing we need to do is say with bullet. So now we're basically moving into saying that we're in the bullets create event here. With this one here, we can say phy rotation equals other dot rotation. Sorry, dot phy underscore rotation. And what this is going to do, this is going to rotate the bullet to be facing the same way that our player is facing. So if I click here, you'll see, oh, sorry, it's inversed. I forgot we need to invert that. So basically, it's going to be negative other dot phy rotation. So what you'll see is that now we get the bullet, and it's facing the wrong way. Oh, I'm sorry, I got that wrong again. It's not negative phy rotation. It's just the fact that the bullet here is actually facing up. So we could say plus 90, I think. 90 degrees is going to turn that to the right. That's better. So now what you'll notice is that the bullet is actually facing the way that it should be facing, but not moving anywhere. That's fine for the moment. I think what we'll do as well is, I like the animation this bullet is having. It works quite well on the map. I think we won't use the traveling animation, so I'm going to delete that from our project, because we're not going to need that. So, back in our object player with the global left pressed, we need to work out the direction to the mouse, which we already have from the step event, and this is the reason why we're doing this inside of the player. It's mouse underscore dir. So in our with bullet section here, we can say phy physics, physics, apply impulse, and that's going to be from x and y, because that's obviously a center point. The x impulse, we're going to call this ldx, and the y impulse is going to be ldy. Just above that, we need to say ldx equals length dir x. It's going to be a length of 15 and a direction of other dot mouse underscore dir plus 90. Do we need to add plus 90? No, I don't think we need to add plus 90 to that. We'll see how that goes. And we'll do the same thing for y. This time it's going to be ldy, and instead of length dir x, it's going to be length dir y. Now hopefully when we click in our game, the bullets will fire in a very strange way. I think we do need to add plus 90 to that. So let's just add plus 90 to that. That's the reason why this is happening, is because the player is facing to the right. Oh, maybe not plus 90. Maybe it is negative. It's maybe negative mouse dir. Let's have a look how that goes. Ah, there we go. Yep, sorry about that, guys. It was negative mouse dir. So what you'll notice is we can fire these animations, these bullets, as many as we like, and the game will start to slow down because they're not doing anything at the moment, but that's not a problem. We can fix that up later. So the bullets coming currently from the center of the player, we want them to be coming from the tip of the player's gun, which we can add in shortly. But now we've basically got bullets in the game, and they're flying away from us quite nicely. So the next thing we want to do is get rid of those bullets after a certain amount of time, because they're going to clog down our game, and we don't want that to happen. So basically, add alarm 0, and inside of alarm 0, we're just going to say instance destroy, and in our create event, we're going to say alarm 0 equals, let's say 30. We'll give it 30 frames to do its thing. Oops, there we go. So basically, the player should never actually see these bullets disappearing from their screen, unless they're in the corner like that, and that's where your bugs are going to come from. So let's increase that to say, if that was 30 and it's going 75% of the way, let's make it 45, because it's not quite 60. 60 is the speed the game's running at, and that should be plenty sufficient. There you go. So now what you'll see is they're actually making it most of the way across the screen before they disappear. So the next thing we need to add is something for them to hit. So let's add a crate to our project. I'm just going to bring a crate in right now. That's a sprite. I'm going to call it SPR crate. I'm going to center that, and we'll create an object for that as well. Let's call this obj crate. I'm going to select the sprite crate, and we're going to stick the user's physics. Set it as a box. Make sure the box represents the crate properly. These default values should be fine. go into your room and just place a couple of crates down. I'm just going to place mine randomly around the player over here. Just give him something to shoot at for the moment. You can replace these with monsters, any type of monster you like. The only reason I'm not doing monsters in this tutorial is just because, you know, everyone's going to have a different kind of monster that they want to implement, and really it's up to you guys to decide how you want to implement them. I'm just going to show you guys how to get these basic mechanics up and running for your games. So anyway, with the object crate, I'm going to add a collision event with crate so that they can collide with each other. And I'm just going to add my standard do this comment into the action. I'm also going to add another collision event with object bullet, and I'm also going to put the do this event inside of that. And I'm also going to add a collision event with the player, and again I'm going to add the do this inside of there as well. So now if you run your game, what you should see, they should collide with the bullets, it should collide with the player, and as you saw, it collided with itself. Now it still looks a little bit spacey, obviously. It definitely shouldn't look like that, and the bullets definitely shouldn't be bouncing off those crates like that either. We can solve that quite easily, because once a bullet has collided with the crate, so in our collision with this, we basically just say instance destroy. That's going to get rid of our crate, and we need to say with other, because other is going to be the colliding instance, so other is going to be the bullet that actually collides. Instance destroy. So basically, delete the bullet and delete the crate if the bullet touches the crate. There you go. Now you guys could, instead of just doing that delete like that, you could add some sort of animation, just spawn in a sprite or something like that, just to show people that an explosion is happening or something, whatever you guys feel like. What I might actually do as well is, instead of just destroying this, I might say alarm 0 equals 5, and that should give the physics system a little bit of time for that crate to interact with another crate as well. So I'm going to say alarm 0, put in a code and say instance destroy. So 5 frames later it should destroy itself, and that should give it just a little bit of time to have a bit of kickback, which means that it should push the other crates over here like that, just like you saw there. Next thing I'm going to do is I'm just going to increase the linear dampening on this until they don't look like they're skating on ice, because that's not a desired effect. See, these crates, they still look a little bit icy, so I'm going to bump that up. What's the player currently set to? Player's set to 10. Let's bump that up to 10 as well. That's better. So now what you'll notice is that they don't float around so much. And obviously in this game, the faster they can click, the more bullets they can spawn. That's fine for this at the moment, but you can time that with a timer. You can, use an alarm to make that go a little bit slower as well if you want. Now for the final part of this tutorial, we're going to add just a little bit of polish and maybe some scope to the player. So you press right click and the scope shoots out just a little bit, something like that, I think. So what we'll do is we'll create a new object, and we're going to call this one object underscore camera. We'll place one camera in the room, and we'll just place him near the player. It doesn't matter, anywhere is fine. And in our player's step event, yep, this one will be fine. We're going to have another piece of code. I'm just going to comment this so it says control camera. Now all we need to say is object camera dot x equals lerp. So we want to linear interpolate from the object camera dot x to the player's physics position, phy underscore position x, at a speed of 0.1. We're going to do the same thing for y. And what this is going to do is it's going to give us a nice slow animated camera, rather than just a stuck to the player harsh sort of camera like it currently is. And go back into your room and set that object following to be object camera. Now when we run the game, the camera will slowly follow the player, and you'll see, oh, I think we got some numbering wrong there. I think that needs to be back in our player, in our control camera event. I've just gone X here, it needs to be Y. So what you'll see is the camera, now if I move, it takes its time and then catches up. Oh, slight bug there. You see these crates, they rotate a lot. We can fix that with some angular dampening, like we did with the the linear dampening. Let's bump up their angular dampening a little bit. So I'm going to make mine 10. Let's have a look what that does. There we go. So now they just sort of don't really have much lingering rotations to them, and they shouldn't because they're crates. Crates, I mean, it depends on the surface that they're on. You can do a calculation check and go, okay, is it on ice? Give it some extra angular and linear dampening, but if it's on this hard concrete, I don't think a heavy crate would have much spin to it. So this is pretty much the basis of a top-down shooter. This is quite an expandable framework. One other thing I might do really quickly is just get that bullet firing from the tip of the gun rather than from the center of the player. Let's do that. It's just going to make the game look a little bit nicer. So in our global left press event, what we need to do is, let's have a look. What we're doing here, X and Y. So we need to work out a new X and Y position. So this is basically going to be slightly out of the player a little bit and then slightly to the right. So what we do is we'll just call this one here LDX. We're going to use the same thing, length dir x equals length dir x. It's going to be 14 pixels out, and we'll just say mouse dir. We'll do the same thing for Y. 14 pixels out, so that needs to be negative mouse dir. There we go. So basically this is going to give us 14 pixels away from the player. It'll make sort of a ring. If I set this to 32, I'll give you guys a quick example of how this works. So in here where we're spawning at the X position, we're going to say X plus LDX. And then for Y, we'll do the same thing, but some will say Y plus LDY. Now, because I've set this to 32, I should be able to exaggerate the effect. Now you see the bullets coming from, if I spawn these fast enough, they're spawning over here where my mouse is, not back inside the player like it was before. Now this already looks a little bit better than it did, but we can fix this as well by adding just a little bit more to our X position than our Y position. Or we could actually do this also by increasing mouse dir. So if we added, say, 20 degrees to this, what that would do is that would also shift our weapon across a little bit. See, now our weapon is spawning from the left of our player, so it's definitely not 20, probably negative 20 degrees. Let's try that one out. And again, this is just, experimenting with the numbers. Okay, so 20 degrees is probably a bit too much. Let's try 12 degrees. That looks much better. Definitely it's coming from the center of the gun rather than the center of the player. Now all we need to do is bring that back inside of the player so that it doesn't spawn outside of the player like it was before. And that should spawn, so I set those to 16. Now the bullet should spawn underneath the fire of my gun. It just makes it look a little bit nicer. I'm just going to try and kill all those crates. Right, so that's basically the basics of a top-down shooter. Is there anything else polish-wise we can do? Scope. Let's add a scope to our game really quickly. So jump into your object player, and this time we're going to add let's add a global right mouse pressed. Actually, sorry, let's add a global right button. And inside of this, we're going to say btn right equals true. Actually, you know what? We'll call this scope. Scope equals true. Now we're going to add a global mouse right released, and we're going to copy that code, and this time we're just going to say scope equals false. Sorry, I'm going to change that mouse button to global mouse right pressed. I think right pressed would work just a little bit better because I'm doing the handling of scope myself. Now in our create event, we're going to say scope equals false because we need to initialize our variables before we use them in the step event. I'm going to jump back into our step event control camera script. Now in here we need to say ldx equals 0. We're using these same variable names again. ldy equals 0. Actually, we probably shouldn't use those variables because they're... Oh no, they should be fine. Um, actually no, they're used over here, aren't they? Yeah, they're used for firing. Alright, let's call this CDX for camera. We'll call this cam underscore DX. Cam underscore DX, there we go. Equals 0, and then all we need to say is if scope. So basically, if the scope is being pressed, then we need to apply some extension to that. So basically, we do the same thing. Let's basically say cam underscore DX equals length DX, and basically in a top-down shooter, these length dir functions are going to be your best friends. So get used to these guys because they're pretty good. Let's increase that by in 128 along negative mouse underscore dir, and we'll do the same thing for y. So cam dy equals length dir y plus 128 pixels. Now for the camera's x lerping position, it's going to be the player's position plus cam dx, which is going to be the offset, and plus cam dy for the y offset. So basically what happens is these default to 0, so it's the player's position by default. If you right click and the scope is then activated, that gets set to 128, and it gets set to 128 pixels in the direction that we're facing, away from us, and then basically the camera is trying to get to that position, and we should get a bit more vision in that direction. So if I right click, you'll see we get a bit more vision in that direction. Now 128 is probably a bit too much because you'll see my screen is only 320 by 240 pixels high, so going 128 pixels is a little extreme. Let's maybe make that 64. Might look a little bit better, obviously because the game's not perfectly round. So now we've got some sort of scope. There we go. And the other thing we can do in this is we can say, if you wanted to add like a laser scope or something like that. I'm just going to add some stuff to this so show you guys some options, but basically in your draw event you could add something similar to say draw self, because we always want to draw the player first, and just underneath the player we'll say something like if scope, then you say draw line from the player's x and y position to the mouse x and mouse y position, and that'll basically give you a bit of a scope. There you go, some sort of scope if you're zooming in. That could be red if you wanted to, so draw line, I don't know what the color is, draw line color, x and y to mouse x, mouse y, see red, and that's going to give you a red scope. There we go, so now we've got a bit of a red scope. If you wanted that scope to be coming out of the tip of the gun and rather than the center of the player, we just use that exact same code that we used for the bullets for calculating its position, and we're just going to do that inside the draw event this time. We're just going to call this DDX, that's going to stand for draw dir x 16 in negative mouse minus 12 degrees, and we just apply that to the player's x and y position, so plus DDX and plus DDY. And if I give that a quick run, you should notice that the scope should now come from the center of the gun. There we go. And again, if you wanted, just another option, so this is just one type of scope, the short scope. If you wanted a long scope, you could do the same thing, plus DDX, instead of mouse X and mouse Y, plus DDX. I'm just going to cheat here and just say DDX multiplied by, that's DDY, and just multiply these DDX values by, say, 100, because my screen is going to be smaller than whatever that value is. And this is just going to draw a line off my screen from my offset position here at the start. So if I right click, you'll get a scope that goes all the way from the center of the player outside. Now obviously 12 degrees here looks like maybe it's not the right number to be working with. Let's try a lower number, like say 8 degrees. There we go. That looks a little bit better, but basically you get the idea. Tweak with these numbers until you get something that looks better for you. And yeah, so thank you guys for watching. I hope you've enjoyed this series. This has been the top-down shooter tutorial, or at least the basis of a top-down shooter tutorial. If you want to see more of this video, please like the video and subscribe to the YouTube channel. Leave comments, any questions, things like that. If you have any more requests for the top-down shooter tutorial, please leave them in the comments, and I'll probably collect them all together into a big list and come back to this tutorial series another time. So thank you guys for watching. I hope you enjoyed it. Bye.